Alright, so in this video we're going to continue our discussion on indefinite integration. So here we're presented with a problem, and again, remember this symbol here is telling us to find the function whose derivative is this here. So all this stuff here, again, all this integration symbol here, sorry, is just telling us, find the antiderivative of this function here. Now, before we even try and find the antiderivative, we might want to try rewriting this problem to make it a little bit easier for us to do. So what I can actually do is rewrite this the following way. I can say that this is the same thing as x squared over x to the fifth plus 2x over x to the fifth minus 5 over x to the fifth, and we want to find the antiderivative of all of this. So this will be all with this dx there. And the next thing that I can do is apply my rules of exponents. So the next thing I need to remember is, well, when I'm dividing two things that have the same base, I can just subtract these exponents. So this turns into the integral. Now keep in mind I have x squared over x to the fifth. That'll turn into x to the negative 3, if you think about 2 minus 5. Here you have x to the 1, so this will turn into 2x to the negative, well, you'll have 1 minus 5, that'll be a negative 4. And then here we have minus 5, and there's no x's to subtract, but what I can actually do is just move. I can move this whole guy right here, I can move him to the numerator. So I'll have x to the negative 5. And keep in mind that I'm just going to put parentheses on all of this, and we have dx right there. Okay, so if I continue working out this problem, I can now apply the power rule that we learned. This is just going to equal, remember that you add 1 to the power, I'm sorry. So we're going to add 1 right there. So negative 3 plus 1, that's going to give us x to the negative 2. And I'm going to divide by that new power, negative 2. And notice that if you take the derivative of this, negative 2 would come here. So you would have negative 2x to the minus 3. And these two negative 2's would cancel out, leaving you just with x to the negative 3. Moving on, we now have this one here. So I'm looking at this term now. I have 2x to the negative 4. Remember, I'm going to add 1, so I'll have negative 4 plus 1. That's going to give us plus 2x to the negative 3. And then remember, I divide by that negative 3. And then finally, we have, let me change my color here to green or something. We have 5x to the negative 5th. So remember, I'm going to add 1 here, so I will have minus 5 x to the, and then negative 5 plus 1 is going to give us a negative 4. And then remember, we're going to divide by negative 4. And then finally, all I have to add on is my plus c. Now here, all I'm going to do really is just clean this up a little bit. So this is going to be the same thing as negative x to the negative 2 over 2. Here, I have a positive 2 over negative 3. That's going to turn into minus 2x cubed. Oops, I'm sorry, 2x to the negative third power over 3. Here, the two negatives will make a positive, so that'll give us a 5x to the fourth, a negative 4, sorry. And this is all over 4, and then we have our plus c. And what we've essentially done here is we're saying that, hey, if you take the derivative of this, so if you take the derivative of this, you can get back this, which is the same thing as what we originally started with. So again, when you see this integration symbol, all this is telling you to do for right now is just find the antiderivative, find the function whose derivative is given by this here. We can look at another example really quick. Let's see, I'm going to run out of room. No, this will be fine. I can squeeze it in here. So I want you to find the derivative, or I'm sorry, no, find the antiderivative whose derivative is given by x plus 6 over the square root of x dx. So pause the video, try and find this. and see if your answer matches up with what we get in just a second. So assuming that you've paused the video and that you've worked through this problem, I'm now going to work through it. One of the things I noticed is that I have the square root of x in the denominator. What I'm going to do is rewrite that as x plus 6 all over x to the 1/2 dx. And now what I can go ahead and do with this is I can actually separate this and rewrite it just the way I did this example up here. Notice that I rewrote the x to the 5th with this term here, and then I wrote 2x over x to the 5th here, and then the same thing, 5 over x to the 5th was written there. So I can actually just do the same exact thing right here. And so what I'm going to end up having is the integral. And the first guy, we're going to have x over x to the 1/2. And then we're going to have plus 6. So plus 6 over x to the 1/2 dx, right? Dx. Now, this here this is really x to the 1. So I need to simplify this a little bit. This is really x to the 1. And what I want to do is I want to reduce this. And remember, you have to subtract your exponents. So this right here will turn into the integral. X to the 1, so I'll show the steps here. You'll have x to the 1 minus 1/2. That's really what it becomes. And then we're going to have this positive 6, so plus 6 to the times x to the negative 1/2. And then we have this dx here. Okay, so I'm pretty much ready to do this. All I have to do is just simplify this. Now 1 minus 1/2, that'll be, well, 1 take away 0.5, that's 0.5, right? So this right here will just turn into a 0.5. So let me just go ahead and write 1/2 right there. So we'll have x to the 1/2. And now I can just use my power rule. So the power rule says that we add 1. So I'm going to add 1 to that and then divide by whatever I get. So I have x to the 1/2 plus 1. Well, 1/2 plus 1 is 3 over 2. And now I'm going to divide by 3 over 2. And then I'll have plus 6x. And remember, I add 1 here. So I'm going to add 1 there. So negative 1/2 plus 1, that's positive 1/2. And I'm going to divide by 1/2. And then I have this plus c. Now, keep in mind, I can simplify this a little bit more. Keep in mind that when you're dividing by a fraction, it's the same thing as multiplying by the reciprocal. So this guy right here is really the same thing as 2 over 3 x to the 3/2. The same thing here. You have 6 over 1/2. Well, that's the same thing as multiplying 6 times the reciprocal of 1/2. Well, 6 times the reciprocal of 1/2 is 2, and 6 times 2 gives us a 12. So that'll turn into a 12, and we'll have 12x to the 1/2, and then we tag on this plus c. And so what we've essentially done is we found an antiderivative. So this is an antiderivative whose derivative is this guy right here. So this again is the, let me go ahead and backtrack that. This here is the derivative. And what we found over here, this guy right here, this right here is our antiderivative. And I encourage you to check your work and take the derivative of this and see if you can actually match that with what we had here.